You build a banking app, you hand it to your test lab, and it opens to a blank white screen. No error you can act on, just a quiet message that says this device is not supported, and then nothing. Your emulator grid, the one that runs every other app you own, cannot even get past the front door. The app looked at the machine it was running on, decided it was not a real phone, and refused to start. Today I want to explain why fintech apps do that, and why a real device is the only thing that gets you in. I run over 100 real cloud Android phones in Singapore, genuine Samsung handsets, each on its own persistent Singapore mobile IP on a real carrier SIM, reachable over an ADB endpoint with an API to list and lock any phone in the fleet. So here is the verdict up front. Banking and fintech apps are the one category where a real device is not a convenience, it is the entire requirement, because these apps are built to distrust the hardware first and the user second. Let me show you what they actually check. Most apps assume the device is friendly and only worry about the account. A banking app assumes the opposite. It treats the phone in its hand as a potential attacker until proven otherwise, because the money is on the line and the fraud teams behind it have learned the hard way. So before you type a username, before a single screen loads, the app is busy asking one question. Is this a real, unmodified phone, or is it something pretending to be one? The first thing it looks for is an emulator, and emulators are surprisingly easy to spot. A real phone has a pile of sensors, an accelerometer, a gyroscope, a light sensor, a real camera, real telephony hardware, and a built fingerprint that matches a shipping retail device. An emulator fakes some of this and forgets the rest. The accelerometer reads a flat 0. The model name gives it away. The telephony stack is hollow. A fintech app checks a dozen of these tells at once, and a single mismatch means the door stays shut. The second thing it looks for is root. A rooted phone is one where the owner has taken full control of the operating system, which also means malware or a tampering tool could have that same control. Banking apps refuse to run on a rooted device for exactly that reason. They scan for the traces root leaves behind, the extra binaries, the modified system partition, the tools people use to hide it, and if they find any of it, they close on the spot. And the third thing, the one you cannot talk your way around, is hardware attestation. Modern Android has a feature called Play Integrity, where the phone's own secure hardware signs a statement about whether the device is genuine and untampered. That signature is minted inside a chip that software on the phone cannot reach or forge. A real handset produces a strong verdict backed by that hardware. An emulator simply cannot, because it has no such chip to sign with. This is the wall that no clever configuration ever gets over. So here is the problem this creates for a real test team. Your continuous integration runs on emulators, because emulators are cheap. They spin up in seconds, and they scale to a whole grid in the cloud that works beautifully for almost every app you will ever build. And then you get a fintech client, or you add a payment feature, and suddenly your entire grid is useless, because the one app you most need to test end-to-end is the one app that will not even launch on it. The only honest fix is a real device, because a real device passes these checks by simply being what it claims to be. There is nothing to fake, nothing to hide, and no attestation to forge. The sensors are real, the operating system is stock, the secure chip is present and signs an honest statement. The app looks at it, sees a genuine phone, and opens the way it is supposed to. That is not a trick, it is the absence of a trick. And it is not just the hardware, the network side matters just as much for a fintech app. These apps expect a real phone number on a real carrier, because so much of the flow runs through it. The one-time code arrives by SMS to the same device the app is on. The risk engine checks whether the number, the SIM, and the IP all line up like a normal customer would. A real carrier SIM in a real phone gives it all of that, where an emulator gives it a phone number that belongs to nothing. And if your customers are in Singapore, the network is not a detail, it is the test. A real Singapore carrier SIM means your app sees a local number, a local mobile IP, and the local payment rails your customers actually use. A pay now prompt, a bank redirect, an SMS from a Singapore shortcode. Run that on a phone sitting overseas on a data center address, and it tells you almost nothing about the experience a real customer here will have. A phone that is genuinely in Singapore tests the thing you are actually shipping to people who are genuinely in Singapore. Which means a real device is the only way to test the part of a fintech app that matters most, the onboarding. A new customer signs up, enters a phone number, receives a code, points the camera at an identity document, and the app decides whether to trust them. You cannot exercise that flow honestly on a machine with no camera, no SIM, and no real number. On a real handset, you can walk the whole path exactly as your customer will, and find the place it breaks before they ever do. cloudf. Fintech apps lean hard on a second factor, a one-time code by SMS or a prompt from an authenticator, and both of those live on the device. To test that your two-factor flow actually works, the code has to arrive somewhere, you can read it and feed it back in. On a real cloud phone, the SMS lands on the phone, the authenticator app runs on the phone, and your test can complete the loop the way a person would, instead of guessing at it. There is also the whole layer of alerts a fintech app lives on, and those only fire properly on a real device too. A transaction clears and the app pushes a notification. A login triggers a security warning. A payment prompt arrives and has to be tapped within seconds. Push delivery leans on real Google services running on a genuine phone, and it behaves differently under a real mobile network than it ever does on a local emulator. If you want to know that your alerts actually reach a customer in time, you have to watch them land on a real handset on a real carrier. There is one more thing banking apps do that quietly wrecks test setups, and it is device binding. Once you enroll, the app ties your account to that specific phone so that a login from a brand new device triggers a fresh round of verification. That is great security and a nightmare for a test lab that hands out a random throwaway machine every run, because every run looks like a suspicious new device and gets challenged all over again. This is where a persistent phone earns its keep. If the same handset, with the same SIM and the same mobile IP, is waiting for you every session, then the device binding survives from one test run to the next. Your enrolled account stays enrolled. Your automation is not fighting a verification wall every single time, and you are testing the steady state your real users live in, not an endless first day. A stable identity is not a luxury here. It is what makes the tests repeatable. And all of this automates, because a real cloud phone is still a phone you reach over at deep. You point your existing test framework at its endpoint, drive the app the same way you would drive an emulator, and run it as a step in your pipeline. The difference is that the device on the far end is genuine, so the app actually runs, the attestation actually passes, and the results actually reflect what a customer will see. Real does not have to mean manual. And because a fintech app behaves differently across Android versions, you rarely get away with testing just one. A security check that passes on last year's build can fail on this year's, and an attestation verdict can tighten with an update you never asked for. A small fleet of real handsets on a few known versions lets you run the same flow across all of them and see which one breaks, instead of shipping and learning about it from a customer whose bank login suddenly stopped working. That is a matrix you can only build out of real devices. I should be clear about what this is for. Testing your own fintech app across real devices, real numbers, and real networks is exactly the kind of work a real device cloud is built for, and it is completely above board. What it is not for is dodging another company's fraud controls or running accounts against the platform's rules. The whole value here is honesty. You are giving your own app a genuine device, so your own testing tells you the truth about it. And a real device does not fix everything, so let me be honest about the limits. A genuine phone will not rescue a badly written test that races the UI, and it will not make a flaky assertion pass. There is a little more latency reaching a phone in a rack than an emulator on the same box, so your timeouts need a bit of room. A real device removes the one wall emulators cannot climb. It does not remove the ordinary discipline of writing good tests. The reason most teams do not just buy a shelf of phones is that a real device lab is genuinely painful to run. You are buying handsets, seating real SIMs that cost money every month, flashing them, keeping them charged, without cooking the batteries, updating them, and reaching them over the network from your build servers. Do that for one phone and it is a weekend project. Do it for a fleet you can rely on, and it is a whole job, one that has nothing to do with the app you are actually trying to ship. That is the whole reason cloud.one exists. Real Samsung handsets in Singapore, on dedicated hardware, each with its own persistent Singapore mobile IP, on a real carrier SIM, Singtel, StarHub, M1, or Vivify. Not an emulator, not a data center address. A genuine phone that passes the emulator check, the root check, and the hardware attestation because it is exactly what it says it is. You reach it over an ADB endpoint, list and lock it through an API, and watch the screen live in your browser. Start at cloud.one and use code YT30 on your first month. So to recap, Fintech apps distrust the device first, they screen for emulators, they refuse to run rooted, and they demand a hardware-backed attestation that only a genuine phone can produce. That is why your emulator grid cannot even open them, and why a real handset can add a real carrier SIM and a persistent identity. And you can finally test onboarding, one-time codes, two-factor, and device binding the way your customers actually live them. A banking app is built to trust a real phone and nothing else, so give it a real phone, test it honestly, and ship it knowing it works. I'll see you in the next one.